Let's continue with question number 2. The wind chill is the temperature in degree Fahrenheit a human feels based on the air temperature in degree Fahrenheit and the wind velocity v in miles per hour. If the air temperature is 32 degrees Fahrenheit, then the wind chill is given by W of V equal to 55.6 minus 22.1 V to the 0.16, and is valid for the V between 5 to 60 inclusive. Part A, find W prime of 20. Using correct units, explain the meaning of W prime 20 in terms of the wind chill. Part A, there are two ways to find the answer. You can type in this function into y1 and then you do, the derivative for y2 and then you do y2 of 20. I'm going to show you how to find a derivative by hand and then use a calculator. So now you're going to find W prime. So you have to use W of V equal to 55.6 minus 22.1 and V to the 0.16. So now you have to find the W prime of V. So this is V. So we usually don't see V, we saw X and T. So you just imagine you doing W of X equal to 55.6 minus 22.1 X to the 16.16. You imagine this is X, okay? So now you get the derivative of the 55.6. So the derivative will be 0 minus 22.1. So imagine this is X. So now you bring the exponent to the front and then say the same, and then you subtract exponent. So now W prime of V equal, now we just simplify a little bit. And then subtract, you get negative 0.84. So now we do W prime of 20. So now we're going to substitute 20. So now we're going to type it into calculator. So we're going to get negative 22.1 times 0.16 and then times 20 to the negative 0.84. So we will got negative 0.2855. You can use a calculator to find the y1 equal to this, and then y2 become a derivative, and then you do y2 of 20, we get the same answer. Okay, so now let's focus on finding the correct unit. So we get W prime of V. This is a function of V. So some people say, how do you find the unit? This mean basically is dW dV. Okay, think about if you had W prime of T, that means dW dt. If you have W prime of X, that means dW dx. So now W prime of V will be dW dV. So now dW dV, it means delta W over delta V. So let's find the unit of the W. So we set that over here in the beginning. The wind should have a unit of degree Fahrenheit. So we put degree Fahrenheit. And then for the V, the V in mph. So we put mph. So now we finish finding the unit using the slope notation. So we finished the W prime 20 and we find the correct unit. Now we're going to explain the meaning. So now W, it means the wind chill. This is the slope. So that means the rate of change of the wind chill is negative 0.2855 degree Fahrenheit per mph at V equal to 20 mph. Okay, so this is one of the version you can write. You can write another one, or because the slope is going to be negative, so then you can say that the wind chill is decreasing, decreasing at a rate of 0.2855 degree Fahrenheit per mph at V equal to 20 mph. Okay, so we finished part A. Let's take a look at part B. Part B. The question said that find the average rate of change of W over the interval V between 5 and 60 inclusive. Find the value of W at which the instantaneous rate of change of W equal to the average rate of change of W over the interval 5 to 60. So we had two parts to find. So step number 1, you're going to find the average rate of change of W. So let's translate, see what I mean. Average rate of change of W, okay, on the interval. So now rate of change means W prime, and then you have to find the average of W prime on the interval. So that will lead us to the formula, integral 5 to 60. W prime, or what variable, V dV over 60 minus 5. So over here, there are two ways to find the answer. If you already know the function of this one, you get to type in the integral of this function dV, and then you divide by 55. If you don't want to use the derivative, you can use the FTC. The antiderivative of this is going to be W. The antiderivative of W prime is W. So you will get W of 60 minus W of 5 over 55. And we had the function W given to us. Okay, so now we are going to use our calculator. Okay, so you are going to make your Y1 equal to the W. So 55.6 minus 22.1, use X. And then over here, behind the scene, you do Y1 of 60 minus, okay, Y1 of 5. And then you get the answer, and then divide by 55. So we got this number. So we have negative 0.25397. Okay, so we got negative 0.2537967. So now let's take a look at the next part. Find the value of V at which the instantaneous rate of change of W equal to the average rate of change. Okay, so that means this one. So basically find V when instantaneous rate of change, that means W prime of V equal to negative 0.25397. So we found this one before, okay? You can copy down that equation. So we found the in part A, which is negative 22.1 times 0.16 times v to the negative 0.84 equal to negative 0.253797. Then we can make this y1 and this is y2 and find the point of intersection. So let's refresh what we did before. So I already made my y1 equal to w, and then I'm going to make my y2 equal to the derivative w prime. Okay, and then this is going to be the the right side, the negative 0.253797. So I'm going to make this is y2 and this is y3 and make them equal. Okay, so this is y2, this is y3. Now I have my y2 and y3, and then I'm going to graph them. So usually you will set your window into this square window, and then we're going to graph. Don't forget that you had to highlight the two that you want to graph. Okay, so now we're going to graph. Okay, so it looked like the point intersection over here. So we cannot see, so we don't change the window. So I'm going to make my x mean equal 0. I'm going to make this into 50. It looks like it's very close to the x-axis, so therefore I'm going to shrink the y value. Now we're going to graph again. And then we're going to do second trace, number 5 intersection. And then you're going to do first curve, second curve, and guess. And then you will see that 23.0109, so 23.011. So we got V means X, 23.011. So we found our V, that is a point intersection. So we finished question number 2B. Let's take a look at 2C. 2C is that over the time interval 0 to 4 hours inclusive, the air temperature is a constant 32 degrees Fahrenheit at T equals 0. The wind velocity is 20. So at T equal to 0, B equal to 20. If the wind velocity increases at a constant rate of 5 mph per hour, so that means this is a linear because constant slope is only happening in linear. Okay, so M of B, V prime of T equal to 5. So what is the rate of change of the wind chill with respect to time at T equal to 3? So this one they ask you to find the rate of change, that means the wind chill by W prime at T equal to 3. So that means W prime of 3 and T equal to 3. So you need to find the function of time. Okay, so we need WT because you have T equal to 3. So if you look at what we had in the beginning, we get W of V equal to 55.6 minus 22.1 and V equal to the 0.16. This is a function of V, but you want to turn it into a function of T. There must be a reason they gave us this. they gave us the v is a function of time, the slope is a constant phi, and at t equal to 0, you get 20. So basically it means v of t equal to phi t plus 20, 0, 20. Okay, that's the initial amount, which is a y-intercept. So v of t equal to phi t plus 20. If I do the composition function and substitute the v by phi t plus 20, then I can turn this into a function of time. So that means if I substitute v, I will get this. V turned into phi t plus 20. So now I get wt, become a function of time. I just have to find the derivative of this and then replace t by 3. So now I'm going to find w prime of t, because now it's a function of time. Derivative of number 0 minus 22.1 stay the same. I have to use a chain rule, okay? The base, the exponent, 0.16, and then you get phi t plus 20. The exponent subtract 1. And now I'm going to find the derivative of this, the inner, which is phi. Now I'm going to simplify a little bit. And next I am going to replace t by 3. 5 times 3 is 15. Very last step. I'm going to type in this into my calculator. So I get negative . So now I'm going to get negative 0.8922. So very last step, you have to find the unit. So we had w prime t. W prime of t, it means dw dt. So delta w, delta t. For what's the unit for w? Degree Fahrenheit. What's the w for t? We're talking about that is 3 hours. So therefore, it's going to be hour. So therefore, the unit is degree Fahrenheit per hour. So now we finished the question number 2C.